All right, Unit 3, Lesson 4. Today, what are we learning? We're going to learn how to graph the sine and cosine function values. So last class, we talked about solving for function values. Today, we're going to graph. Specifically, it says here, when you graph sine and cosine functions, the way it works, that's weird how it changed colors on me. Let's try this again. When you graph sine and cosine, what's going to happen is the x-axis is going to be treated as the angle. So for here, just to make sense of this, the theta becomes like the x-axis, okay? So the independent variable, meaning the x, will represent the theta. So theta will be represented by the x. I probably should have the arrows the other way. The theta will be represented on the x-axis. The y will be either the sine or cosine. So y will either be the sine value or the cosine. So this is not where I say sine is y, cosine is x. That's true. But the y value, what it's going to represent on the graph, is actually going to either be the sine or the cosine, the actual value that the hand trick would produce. Okay? What we're going to learn today is that they're going to look like waves. Sine is going to look like a wave originating from the origin. That's the sine. This would be the sine right here. Cosine is going to start its maximum. It's also going to be a wave. And they're going to look like a double, the DNA double helix is what they're going to look like because they're just shifts of one another. But this would be a cosine curve. And you'll see those both today. Okay? So that's what we're doing today. The angle is the independent variable when we graph. The function value itself becomes the dependent y value. Let's begin with sine. So sine represents the y coordinate. Yeah, I'm going to skip a lot of these words. You can read them later. Cosine represents the x value. So first, sine matches up. Make sure you circle this or draw it out to the y coordinate. Sine is the y coordinate. And so when we graph, what we're graphing is basically the vertical displacement. There's a big word there. The vertical displacement on the unit circle. And it will look like a wave that first goes up to its maximum, down to its minimum, and then back up like that. I'm gonna just put an arrow there. This is a periodic function. If you remember that from lesson 1, periodic means it's going to repeat itself over and over and over on its own period. So we're going to have the values come up in a second, so I'm not going to fill this in too much. We call it a sine curve, even though it's a wave. We're going to call it a curve, not a line. It's a sine curve. And the sine of theta, this is just telling you again, it's the y coordinate. Okay, you could say the displacement, the vertical displacement is a way maybe physics teachers might use this, a vertical displacement. Why not throw in some physics when we can? It's the vertical displacement. Do you know the difference between distance and displacement? What is the difference? Because they're very similar. Like, for example, I used to live just right over here. I'd walk to work all the time. I lived approximately a quarter of a mile away. Is that a distance or displacement I just said when I said a quarter mile away? That's a distance. What is displacement? Displacement would say if I walked, let's say it was perfectly east and west. If I walked to the east, you would say I walked distance, positive half a mile. Going home, I'd walk positive half a mile going back if you're talking distance. If you're talking displacement, you would say when I go to the right, you would say it was positive. When I would go to the left, you would say it's negative. Displacement takes into account direction, and negative means for x going left or vertically going down. So when I say vertical displacement, what I mean here is we will have negatives. Notice this graph has negatives. That's just the negative distance, the negative displacement on the unit circle. That means below the x-axis when we correlate. All right, let's start here. We learned hand trick last class, and we're going to go over hand trick values here. So it says the sine period has sine has a period of 2 pi. I didn't say that, but that is the period. That means it repeats every 2 pi. We're going to come up with our table of values going from 0 to 2 pi. Now, I did skip one finger in here, but when you can, we'll fill this out as we go. So I want you to be looking at your left hand. Should probably turn on the video here just to have this on the camera. Let's see here, turn that on. So if I'm looking at my hand, when you look at it, do you look at the palm of your hand or the back of your hand? You're looking at the palm. So as you look at the palm of your hand, your thumb represents pi over 2. Your index is pi over 3, pi over 4, pi over 6. Good. And pinky is anything without a denominator, meaning a whole number. Okay. So, or whole pi, I should say. 0. What do I bend first? Bend your pinky, flip your hand. Y's, we're doing sine. Sine is y. Is the number of fingers above the bend, the square root of the fingers. How many fingers do I have above the bend? Now, to show you the pattern, instead of just putting a 0, I'm going to do square root of 0. And sine and cosine are always divided by what number? 2. On the hand trick. Technically, it's square root of total fingers. So it'd be the square root of the 4 fingers that are left over. Okay, now I will reduce that. Square root of 0 is 0. What's 0 divided by 2? 0. Just put a 0 there. Now we're going to go to the next one. So all the way across, I'm going to write unreduced, and then I will reduce them. Now let's do pi over 6. Which finger do I bend? Pi over 6? Ring finger. Bend your ring finger. Flip your hand. How many fingers do you have above the bend? 1. So I want you to put the square root of 1. And again, sine and cosine are always divided by 2. This will reduce. Square root of 1 is 1. And so we are reduced to 1/2. Okay, next one. Pi over 3. Be careful, I went to pi over 3. Not pi over 4, but pi over 3. Which finger is pi over 3? Bend your index. Flip your hand. What do you get? Square root of 3 divided by 2. Can that reduce? No. So that one I'm just going to put in the middle. Okay, that doesn't reduce. What about pi over 2? Which finger is pi over 2? Bend your thumb, flip your hand. How many y's are left over? So square root of 4 divided by 2. Now that one can reduce. Square root of 4 is 2. 2 divided by 2 is 1. Okay, now I'm going to pause for a second. We need to be thinking in terms of a unit circle. A unit circle has an x-axis here. I mean, that was a y-axis, sorry. Y-axis and an x-axis. What we've done is we've moved along this circle in theta all the way to here. We have gotten to here, pi over 2. Now, as I continue around, what's going to happen is everything's positive in the first quadrant because x is positive and y is positive. But now as I move around, will the y's in the second quadrant remain positive or will they turn negative? The y's will remain positive because I'm above the x-axis. So let me put some markers on here. That's 0. This is 1 whole pi. This will be 2 pi. So the y's are going to stay positive. Okay, let's continue on now. Which fingers are 2 pi over 3 finger? Yeah, which finger is 2 pi over 3? Index. Bend your index, flip your hand. How many y fingers do you have there? Square root of 3. This one will not reduce. Square root of 3 does not reduce, so it's going to be just square root of 3 over 2. What about 5 pi over 6? Which finger is that? Ring. Bend your ring, flip your hand. How many y's do you have there? Square root of 1 over 2. That one will reduce. What's the square root of 1 become? 1. And so this just becomes 1/2. Now we're going to get to pi. Which finger represents a whole number or a whole pi? So you said it first. It's your pinky. Bend your pinky. Flip your hand. How many fingers do you have for y? 0. Haven't got this memorized already? Been practicing that link I put up there? You can be working on it with me then. That reduces. Square root of 0 divided by 2 is the same thing as 0. And it should make sense if you're thinking of the unit circle, if you figured out how it works. We have come to a y value here of 0. I'm not up, I'm not down, I'm on the x-axis. That's why the value is 0. It should make sense. Now I want to point out, as I continue on further, what's going to happen to my y values for the rest of the chart while I'm working from pi to 2 pi? Between pi and 2 pi, these values are going to be negative because I'm down low. Each time it's a negative. Okay. So back to the hand trick. 7 pi over 6. Which fingers are pi over 6 finger? Bend your ring, flip your hand. How many y's do you have there? 1. So it's the square root of 1 divided by 2. Can that reduce? Say yes. What does it reduce to? Negative 1/2. Great. What about 4 pi over 3? Which finger is a pi over 3 finger? Index, pointer, then your pointer, your index, flip your hand. How many y's?
3.
3. Now remember, we're negative, so sneak that negative in. Negative square root of 3 divided by 2. Does that reduce? Nope. Square root 3's, square root 2's don't reduce. Okay, 3 pi over 2. Which one's that? That's the thumb. That represents right here. We have now made it to the negative y-axis, if you will. I know we don't usually call it that, but I'm going to call it that for now. Negative 3 pi over 2 goes there. So we bend the thumb, flip your hand. We are negative because we're down low. How many fingers are left over for y? And what our radius is going to be 2 when you're on the unit circle. What is, excuse me, on the hand tray, I should say. What's the square root of 4? 2. So it's negative 2 divided by 2, which is negative 1. Should make sense. We're down 1 unit on the unit circle. Finally, let's finish this up. Let's wrap our rest of the way. Again, we're staying negative here. Which finger is the pi over 3 finger? Index, your pointer. Bend your pointer, flip your hand. How many y's you got? So it's square root of 3 over 2. Does that reduce? Nope, those do not reduce. Neither does square root of 2 if you had this. Okay. Now 11 pi over 6, which finger is that? Ring, bend your ring, flip your hand. How many y's?
1.
So it's negative square root 1 divided by 2. That will reduce to become what value? Negative 1/2. And finally 2 pi. Which finger is that? Pinky. Bend your pinky, flip your hand. How many y's are left over? 0. Now this is not positive, it's not negative, it's 0. 0 is neutral. Square root of 0 divided by 2 is going to be simply 0. If you look, there's a pattern to these. What happens is we rise. I wish I had more space. It was just getting too small. I would have included the pi over 4s, because what you would have saw happen is it goes square root 0. I'm going to ignore the denominator for a second. You would see it go, the numerators go square root 0, square root 1, square root. I skipped the pi over 4. It would have been pi over 2, or square root of 2. Square root 3, square root 4. Square root 3, square root 2 is skipped. Square root 1, square root 0, square root negative 1, square root negative 2 is skipped. Negative square root negative 3. You see the pattern? It climbs up, then it climbs down. It's a wave, and it would just keep on going back and forth. The word for back and forth is oscillating. It would just keep oscillating between positive square root 4 and negative square root 4, all being divided by 2. So that was a mouthful. State the intervals of x where sine is increasing. Okay, where are we increasing from on, let's just say this is from on the domain 0 to 2 pi. On this domain, where is x, where are we increasing from? 0 to 2 pi, are we always increasing? Where did we stop increasing? We started increasing, where did we stop? Pi over 2, this spot here, and then we started decreasing. So we're increasing from, when you do increasing, decreasing, use parentheses. We increase from 0 until pi over 2. Now, do we increase anywhere else? We increase on this portion. We were increasing. Let me just write it in. This portion, we were increasing. What were we doing in quadrant 2? We decreased here. What about quadrant 3? Decrease. What about quadrant 4? Increase. Okay, so let's fill these in. So if I increase twice, what do you do if you have a second interval? Union. And that second interval started right here. What's that value is that? It's really hard to see. 3 pi over 2. I can clean that up. That's pretty ugly. Let's 3 pi divided by 2. So we started increasing again at 3 pi over 2. And when did we quit increasing on as far as 0 to 2 pi? We went from 3 pi over 2, which is here, until 2 pi. We kept increasing the whole way till 2 pi. That's where we increased. Okay, what about decreasing? Where did we decrease start to finish? When did we start decreasing? Pi over 2. When did we stop decreasing? We're looking at y's here, not pi. We kept decreasing beyond pi. 3 pi over 2. From pi over 2 to 3 pi over 2. Pi over 2 to 3 pi over 2. Hopefully, you're starting to see how the unit circle can help you out on your values here. State the maximum. Okay, so sine is what letter again? Y. On the unit circle, where do I have a maximum Y? This is the y-axis. Where do I have the maximum Y? On the right, the left, the top, or the bottom? The top, which is what value? Okay, now when we start talking about maximum minimums, the theta becomes the independent x. Remember how I said that over here? That when we graph, the theta becomes the independent variable. So that goes in as the x. The maximum would be, I would have an x value of pi over 2. That's the angle that produced the maximum. And how high was pi over 2? You can look on here. How high were we at pi over 2? 1. That's the maximum. Now, where is the minimum? That was the max here at the bottom. This point right there? Minimum at 3 pi over 2. Very good. The minimum occurs at 3 pi over 2. And now we can check our table. What was the minimum function value at 3 pi over 2? -1. So we're trying to tie in a lot of things today. We're trying to tie in the unit circle and the graph. And I have something to show you at the end of class. It'll hopefully make it a little easier to see, but we'll have to get there first. All right, so moving on. To sketch the graphs of basic sine and cosine curves by hand, it says it helps to know the 5 key points. Did I go too fast? No, okay. The 5 key points. What are the 5 key points? I'm going to label them here for you. There are 5 key points. The first one, no, I'm sorry, I'm going out of order. The first is intercepts. Intercepts means x or y intercepts. Is this graph here? This is the sine function. Does this have x intercepts? How many? 3. Does it have a y-intercept? Yes, it's already labeled. The origin is 1. So these are the intercepts, or zeros, you could call them. The zeros occur at these spots. This would be 0, 0. This one would be, again, your x, your independent variable becomes the angle. This would be pi comma 0. And this one would be 2 pi comma 0. When we graph, well, not only will we label intercepts, we'll also do the maximum and the minimum points, the extrema. So how about this maximum? What would be the coordinates for this maximum?
1 over 2.
Pi over 2 first. Your independent is the x-axis, the angle. What's the y value? 1. There you go. And the minimum. Where do we have a minimum?
3 pi over 2.
Now, believe it or not, all those values that we just found in the previous slide, we could plot every one of them on this graph. Those are the values we just wrote down on the previous slide, if you didn't notice. Okay, what's the domain of a sine function? Well, let me add some things. What if I did this here? This doesn't mean continue on up, just continue on the same path, and this. What do you think the domain is? Remember, domain means x values. What is our domain? All real numbers. So you could do x e double r, or if you like, you prefer, you can do from -infinity to positive infinity. Now, what about the range? Does this graph go infinitely low to infinitely high? No, we have a minimum. We said that. We have a maximum. What is the minimum? And I'm going to go purple because I labeled these in purple. It would be -1 in a bracket. Remember, bracket means you attain that value. You get as low as -1 and you do attain it. So it's a bracket. Parenthesis would mean you're heading towards it, but you don't quite arrive. You approach it would be the mathematical word. Okay, how high does this graph get? 1. You could also write it like this if you so desired. Okay, amplitude. Do you remember what how we find amplitude? It was the maximum minus the minimum divided by 2. What's our maximum value we already found? It's on the range. 1, subtract the minimum value, which is -1. 1 minus -1, all divided by 2. What is 1 minus a negative 1? 2. Divide that by 2, you get 1. An amplitude to represent it would look like this. From the midline, I'm using another word that's not on there, the midline to the maximum. That's the length of the amplitude. That's the amplitude there. If you want to label that, that's what we call the amplitude. The period, that's how long it takes to complete one cycle. The way you can do that is find two corresponding points that are on within different periods and subtract from one another. If we had more graph, I would recommend going maximum minus maximum. I don't have two maximums, so I'll do this. This 0 minus this corresponding 0. This 0, the graph is decreasing. We need a 0 where the graph is increasing. It'd be this one. So the value you do, the math is the later x minus the earlier x from the previous period. So it's x minus x. What's 2 pi minus 0? 2 pi. That's the period of sine. It'll also be the period of cosine. Finally, the key points, we've already graphed those. Let's just put labeled on the graph. Labeled on graph. One thing I did not label was that this is a maximum and this was the minimum. That's the only thing I did not label. Okay, and like I said, that table that we did on example 1, those weren't just random values. All those values would fit on this wave, this sine curve. They would all fit on there. All right, so now what do I have you do differently here? I'm giving you what will become the 5 key points. This says use the 5 key points. These are the x values. I want you to find the y values. I've changed this from my graph just slightly. There's only one thing different with the equation I've given you from the equation you had previously. What are we going to do to the y values? You're going to multiply them by 2. So as you come down, the only thing that happens, you could pull these from the previous slide if you want. I'd recommend you practice with your hand trick. But when you multiply by 2, what that does for your hand trick is you don't have to divide it by 2 anymore. Think about it. If you're going to multiply it by 2 and then later divide it by 2, what happens to the 2's? Cancel out. So you can use your hand trick and all you have to write down is the square root values. If that makes sense. If it doesn't make sense, just do your hand trick and then multiply by 2, and maybe by then you'll figure out what I'm talking about. Go ahead and fill these out, plot the points to see what this curve looks like. All right, let's now go on to example 3. This time we're going to look at sine, cosine, and tangent. We're going to do this all together with our hand trick so we have it all in one spot. This time I'm only listing those 5 key points. So just the 5 key points from the sine graph is where I've started off from. So let's see what we get. Let me turn on this one more time. Here we go. Which finger represents our 0 finger? What would be 0? Pinky. Bend your pinky, flip your hand. How many y's do I have there? Square root 0. Okay. Square root 0. And sine and cosine are always divided by 2. Okay. How many cosines? Before I reduce, I'm just going to fill all the way down the chart. How many cosine fingers? 4. You have square root of 4 for cosine. Sine and cosine are always divided by 4. Now, sine is y, cosine is x. The reason I have you flip your hand over is because tangent's y over x, and this puts the y's on top and the x on bottom. How many y's do I have? 0. And how many x's do I have? Square root 4. Okay. See, I'm sorry. I told you the wrong spot here. Make sure you're paying attention on this one because you have the wrong value right now. Okay, this does reduce. Square root of 0 divided by 2 is 0. This one reduces. What's the square root of 4? 2. 2 divided by 2 is 1. This also reduces. What's the square root of 4? Or, excuse me. Y'all told me this one already. 0 divided by 2 becomes 0. So over on the side, just quickly, unit circle. We found the values right here. What we just discovered is the cosine is 1. The sine is 0. Because on a unit circle, it's in the form cosine, comma, sine. We just found the cosine is 1. The sine is 0. Tangent would be y over x. 0 divided by 1 is 0. Okay, now we're going on to pi over 2. This was at the radian of 0. That was 0 there. Now we're going to go to pi over 2. Let's see what we come up with at this spot. So now we're moving along this way. So pi over 2, which finger is that? Thumb. Take your thumb, bend your hand. How many y fingers do you have? So it's square root 4 all over 2. How many cosine fingers do you have? 0. Now, it's going to be the y over x for tangent. Square root 4 divided by square root 0. We're going to now reduce all of these. Square root 4 divided by 2 is 1. Square root 0 divided by 2 is square root 4 divided by square root 0 is, this one's undefined. Now, check it. You don't actually write equals undefined. If you get into AP calculus, they count off for that because you can't be equal to undefined. So usually just draw an arrow through it or something like that and write undefined. I'm going to go diagonal so I can try to fit this in. Undefined there. As a point, again, I could plot this just like I did a second ago. The y is now 1, the x is 0. So on a unit circle, we call this 0, 1. I'm trying to tie together the unit circle. This here is a unit circle with the function values, the graphs. I'm tying them together. All right, let's go around. We're now heading off towards pi. Pi is here. Something's going to go negative. I want to change colors. As I go blue here, what goes negative as you go to the left? The x. So we need to make sure that x values cosine goes negative. All right, take your hand. Which finger is your pi finger? Pinky. Bend your pinky, flip your hand over. How many y's do you have there? 0. How many cosine fingers do you have? So it's the square root of 4 over 2. Finally, for tangent, it'll be square root 0 divided by square root 4. Let's reduce all of those. What is the square root of 0 over 2? 0. What is the square root of 4 divided by 2? 1. And oh, I messed up. I should have put a negative there, which means this is a -1. Finally, what's the square root of 0 divided by, I need to have the negative square root of 4 because the x is negative. What is that? 0. Good. I could plot this as a point. As a point, I don't care about tangent. I do care about the x, the cosine, and the sine. It's going to be -1, 0. That's our value there. Let's continue on this unit circle. We're now going to 3 pi over 2. 3 pi over 2. It's going to be right there. I'll do these values in purple. 3 pi over 2 is now what we're calculating. So going back to our hand trick, which finger is our 3 pi over 2 finger? Not the index, not the pinky, not the middle finger. That's pi over 4. Thumb. Bend your thumb, flip your hand. So how many y's do you have there? Square root 4. How many x's do you have? And so if you have 4 over 0, square root of 4 over square root of 0 for tangent. Let's reduce all of this. Square root of 4. Oh, keep getting ahead of myself. What's negative when you're on 3 pi over 2? The y's. This needs to be a negative on the y there. That needs to be a negative on the y there. Okay. So simplifying, what does this become now? -1. What about here? 0. And so do I do an equal sign? No. We're going to call that undefined. And again, I could plot this point. 0 for the x, -1 for the y. To go all the way around to finish our wrap, if I go all the way around, how many radians go there? This is 2 pi. You might notice, you're going to learn this tangent repeats its values on every 1 pi. Sine and cosine, it takes 2 pi's to get through all the values. Tangent repeats every 1 pi. Its period is shorter. Okay, now I'm going to 2 pi. Which finger is 2 pi? Pinky. Bend your pinky. Flip your hand. How many y's do you have? 0. How many x's? And I should have told you, what are we, positives or negatives on the x when you're here? positive. And y is obviously going to be 0. And then finally, so it's square root of 0 over square root 4. When I go to simplify those, we get 0, we get 1, which we already have plotted, and this is equal to 0. There's our chart. Question over the unit circle, question over the table here. No questions on that? All right. So we skipped some fingers on that. We were just going off the key values of sine, the key values. That's where I pulled those, the 5 key points. Okay, all the other points are somewhere in between. Let's go to example 4 now. I'm going to start throwing in some transformations. So it says complete the table for the 5 key points for the parent function graph. Now, let me explain what's going on here. You see this first column that has all these numbers and these coordinate points already plugged in? Those are the 5 key points we've already found today. They're already given to us. We've already found all 5 of those. What we're going to do is look at this transform graph, and we're going to put in our rule and find the transformed 5 key points. Okay, so don't leave my camera on. I'm going to slide that off here. The rule this time. Let's look at this function here, and I want to put parentheses around this 2x. You don't have to have them there. I'm putting them there just so you can see easier. This -3. Is the -3 going to change my x's or my y's? What do y'all think? Is that inside the sine function or on the outside of the sine function? Outside. Outside is x is horizontal or y is vertical? Vertical. That's going to multiply the y's. Do y's tell the truth or liar? Should ask that one. Truth. You marry your wives, you dump your x's. X is liar, y's are truth tellers. So what the rule here, leave a blank for x, put -3y. Close your parentheses. What's going to happen to our x's? Well, it looks like multiply by 2, but x's are liars. So we're not going to multiply by 2. What are we going to do instead? You said it. Divide by 2. So we're going to take each of these points and apply that rule. And I'll do a different color per so you can see it labeled. The key point 0, 0. What happens to it? Well, it becomes 0 divided by 2, comma, -3 times 0. That's what happens to it. Well, what is 0 divided by 2? And what is -3 times 0? So that one does not change at all. It's not transformed. That point gets there. That's still a key point. Still a 0. Okay, let's find our next. How about here? I'm going to take my pi over 2. Pi over 2, and I'm going to divide that by 2. I'm going to take the -1. We have -3 times 1. Let's simplify those. What happens when you take a pi, you divide it by 2, and you divide it by another 2? How about this? If I had a pizza that had 8 slices, pi is going to be the pizza here, and you cut it in half. How many slices do you now have? 4. And you cut it in half again. 2. So 8 slices became 2 slices. How'd that happen? Well, dividing by 2 and dividing by 2 is the same thing as just dividing it by 4. We take our pi, we divide that by 4. So pi over 4, comma, and -3 times 1 is obviously -3. We're going to plot that point. So if this is pi over 2, this here is pi over 4. That's halfway to pi over 2. Go down to -3, place that point. There it is. That's pi over 4, comma, -3. I'll go ahead and put a 0, 0 there. Let's go to our next point. This one will be easier. You take your pi, and what am I going to do to this pi? According to the rule, divide it by 2, and I take my 0, and that's going to get multiplied by 3. So it's just pi over 2, comma, 0. Pi over 2, comma, 0. That's that point there. Pi over 2, comma, 0. Okay, how about this one? 3 pi over 2. Here we go again. We have a 3 pi over 2, and that needs to be divided by 2. And then we'll have a -3 times a -1. What's 3 pi divided by 2 divided by 2 again? 3 pi divided by 4. And negative 3 times negative 1 is positive 3. So here's 3 pi over 4. Go to positive 3. There's that point. That's 3 pi over 4 comma 3. Last but not least, I take 2 pi and I divide it by 2. And we take negative 3 and we multiply that times 0. What's 2 pi divided by 2? 1 pi. And negative 3 times 0? So now we are going to be able to complete 1 full pi here. So connecting your points, try to round it as best as possible. Try not to do solid lines because they're not straight lines. That's what this graph would look like. So we have vertically dilated it. Use words from Unit 1. We vertically dilated by a factor of 3. We've horizontally dilated it by a factor of 1/2 and multiplied the x's by 1/2. We've also vertically reflected across which axis? If you flip your y's, you reflect it across the x. Yeah. So those are the transformations that occurred, which is just underneath. If you look at this, going in order of the equation, you have a vertical reflection. Let's go ahead and write these in. We have a vertical reflection across. A vertical reflection across which axis did you say? X. When you reflect your y's, it actually goes across the x-axis. We had a vertical dilation. That means we multiplied the y's. How much did we multiply the y's by? The negative was the reflection. So you'd say vertical dilation. I said that plural. Whoops. Vertical dilation by factor 3. Finally, we have a horizontal dilation. Dividing by 2 is the same thing as multiplying by what value? 1/2. Those are the reflections that occurred to create that graph from the parent function of y equals sine x. So we vertically reflected across the x-axis. That means every y value changed from positive to negative or negative to positive. We vertically had a dilation of factor of 3. That means every y value got multiplied by 3. And a horizontal dilation by factor 1/2. Every x value got multiplied by 1/2. Okay. So DOL number 2, allow you to fill in your values here. All right, moving on now to cosine. So cosine function, what I want to draw your attention to is a reminder. Cosine measures what? The x. And so earlier we did vertical displacement. What you're comparing to now on the unit circle is what we call the horizontal displacement. Horizontal displacement. What did displacement mean? What's it similar to? It's like distance, but what's it include? The direction, so positives and negatives. So it's the horizontal displacement from on the unit circle. Now, when you graph it, it's going to appear that cosine is next to a y, and you're going to be like, why is that? Well, that's because when you graph it, the independent's still the angle, but now whatever the x value is on the unit circle becomes a y value on the graph. I'll say it again. The x value on the unit circle becomes the y value on the graph. Okay, here's how it looks. Start at its maximum. Cosine starts at its maximum and then makes its wave. And it would just continue on like that. So it starts at the maximum and it comes through like that. Again, it's a curve. It's not a line. It's not a parabola. It's not an S curve. It's a wave, but we call it the cosine curve. And I should add on here, cosine does go to the left as well, but it hits the y-axis at its maximum peak. Without a transformation, the parent function hits at its maximum peak. Where did sine hit the y-axis? Origin.
0.
Cosine hits at its maximum peak. Okay, so here we go. Just like we started earlier, we're going to do hand trick. So going quickly as possible here. Let me turn this on. Here we go. Hand trick. Which fingers are 0 finger? Pinky. Bend it. Flip your hand. How many cosine fingers do you have there? 4. So it's going to be the square root of 4. The square root of 4 all over 2. This time I think it's going to be faster if we fill these in and then reduce. So I want you to think also on a unit circle. Right now, we are starting at 0. 0 is right here. This is going to be pi. This will be 2 pi. What's in between 0 and pi? Pi over 2. And what's going to be over here? Now I want you to remember, we're going to be measuring the horizontal displacement, which means you're looking at x's. We're going to be positive over here, negative over here, because x is positive on the right. It'll be negative on this side. So on the right side of the graph, cosine, the cosine will be greater than 0 because we're on the right side of the graph over here. On this side of the graph, cosine is going to be less than 0. It's going to be negative because we are on the left side of the y-axis. Okay, so here we go. That was square root of 4 over 2. All right, pi over 6 finger. Which one's that? Ring? Agreed. Ring, bend it. What do you get? Square root 3 over 2. Okay, what about pi over 3 finger? Which one's that? Index, bend it, flip it. How many you got here? 1 over 2. Okay, what about pi over 2? Thumb, bend it, flip it. How many x's do you have there? 0. So square root 0 over 2. 2 pi over 3. Index, bend it, flip it. What do you get here? Square root of 1 over 2. Now, if you're on the left side, we've gone past 2 pi. Are we positive or negative now? Negative. We're going to put a negative there. So we're counting down. Cosine's counting down. Square root 4, square root 3. I don't have space, so we skip it. So to square root of 1, square root of 0. Now we're at negative square root 1. What do you think this is going to be? If you were just going to guess. Negative square root of 3 over 2. Let's check it. Pi over 6 fingers. Your ring finger, bend it, flip it. Yep, that's right. That's square root of 3. What do you think we're going to get here? Negative square root 4 over 2. Okay, now what about here? Let me go ahead and turn this off since we're kind of guessing now. Hopefully you're seeing the pattern. So we've counted down to the square root of 4. What do I now start doing? I start counting back up. So now it's negative square root 3 over 2. Negative square root 3 over 2. This will skip the pi over 4. So we're skipping the square root of 2 over 2. And now I'm at negative square root 1 over 2. What about at 3 pi over 2? What is x on that location? Bend your thumb, flip it. Square root 0. What's going to be 5 pi over 3? Square root 1 over 2. And finally, not finally, sorry, 11 pi over 6. Finally, 2 pi. Square root 4 over 2. Okay, and I'll reduce them all the way through now. What is square root of 4 divided by 2? 1. This does not reduce. This you can leave as is. This one becomes 1/2. This becomes negative 1/2. That stays as is. I don't know what that is. Let's move this over. Maybe that's part of my square root. Okay. This one becomes, this stays. Okay. This one simplifies to become negative 1/2. This becomes stays. This one does not stay. What does that become?
1.
Okay, state the intervals where cosine is increasing. Okay, so what happens at the start on cosine? It's positive and it is increasing, decreasing. What's it doing? What's happening on the x-axis as we go around the circle? You decrease. We decrease from 0 to pi. That's what we do first. We decrease from 0 to pi. What happens once we get to pi? So from here to pi, the x-axis, we're going lower and lower and lower on the x-axis. Now what starts to happen? We increase around here. So we're going to increase this way around. From 0 to 2 pi, we increase. From pi to 2 pi, the function increases. All right. The maximum. Where would the maximum x value be? Think on the unit circle. Just what's the farthest to the right? 0 or 2 pi. That's the max. And what's the minimum?
Pi or 2 pi.
Not pi or 2 pi. Just pi. On this domain. Yeah, this is on the domain here. I'm doing this from 0 to 2 pi is what I'm listing here. State the maximum and minimum. The maximums, this has 2 maximums here. The maximum would be at 0, comma, the angle becomes the x, the independent. The y value becomes your function value, which is 1, 0, 1, 0, 1. That's the maximum. And where's our other maximum? We got 0, 1. Now also 2 pi, comma 1. And then our 1 minimum, the smallest value on here was pi, comma, -1. All right. We've seen that now a bunch of times. Let's label this graph. Key points. We just said there's 2 maximums. Here's one, here's the other. These were our maximums. This was the 0, comma 1. This one would be 2 pi, comma 1. What I'm doing there is I'm pulling the x value and the y value. This right here is our 1 minimum. We said that 1 minimum was at pi, comma, -1. That's the 1 minimum. We have 2 zeros. We haven't labeled those yet. It's pi over 2 and 3 pi over 2. There's our zeros. So the domain. What's the domain for this cosine function? I'm gonna add arrows on them. What do you think the domain is for this cosine function? All real numbers. You can say XERR or -infinity to +infinity. Okay, what about the range? Is that all real numbers? How low? How high? Our range is locked in between -1 and 1. We do attain those values, so it needs to be brackets. You could also do -1 less than or equal to y less than or equal to 1. Okay, amplitude. Remember, that's the maximum. That's the maximum value minus the minimum value divided by 2. That would become that's 2 divided by 2. What is 2 divided by 2? 1. Our amplitude is 1. That means from the midline to the top, it's 1 unit. Our period, you would take any 2 points. The easiest points to pick would be maximums, and you subtract the x's. It's 2 pi minus 0. What is 2 pi minus 0? And the key points, they're labeled on the graph. All right, we could go through the process of doing the same type transformations and seeing what happens here. Let's do this quickly for the sake of time. I want to do this as quickly as possible. What transformation do you see is occurring to this cosine function compared to the parent function we just saw? It's a vertical, what do you call that again? Vertical dilation. We're going to multiply the y's by 1.5. What happens with my x's? Nothing. So it's just going to be 1.5 y like that. So every x, here we go, remains the same, but the y's get multiplied by 1.5, which equals, you don't want to just put parentheses on it. That's going to equal 0, comma 1.5. That's our new maximum, 0, comma 1.5. Let's plot that. Here again, the x does not change, so it's pi over 2, comma, and then it'll be 1.5 times 0. What's 1.5 times 0? There's our 0. Pi over 2, comma 0. Okay. Here we take our pi, nothing happens with it, and we have 1.5 times negative 1.
Negative 1.5.
Negative 1.5. That will be our minimum. There. No, I didn't place that right. Sorry. There it is. I, comma, negative 1.5. And then, again, we're not changing the x, so it remains 3 pi over 2. That's now 1.5 times 0. Which is 0. There's that point. 3 pi over 2, comma 0. And finally, 2 pi. It's going to be 2 pi and 1.5 times our 1. Which equals, and that is also a maximum. Connect these. Again, as best you can. Whoops, I kind of missed. As best you can, make yours curved, because it is a cosine curve. It's not a line. It's not a set of V's or anything like that, or a W or anything. It's a curve. What type of transformation did we say this was? Horizontal. We call it a horizontal, different D word. Not displacement, that means the measurement. Horizontal dilation by factor 1.5. Wait, why did we say horizontal? It's not horizontal. Sorry. Vertical. Check that. Vertical. There we go. Vertical dilation by factor 1.5. Vertical, because we're multiplying y's. All right. Wrapping it up here. We could do these. I'm going to give you the rule. I just did the one that's actually listed as your DOL. Whoops. So on this one, all I'll do is the rule, and then I'll leave this for you as a DOL. This time, what's happening? Let's go in order of x, then comma y. It says to multiply by 1/2. Is that what we'll actually do? What will you do instead? This multiplying by 1/2, multiplying by 1 doesn't change anything. It says to divide by 2, but x is a liar. So what am I going to do instead? You're going to multiply x's by 2. What will you do to the y's?
Minus 2.
Okay, and so this one for transformations, when you multiply x's by 2, that is a horizontal dilation. But we will have two different vertical ones. You will have a vertical, the negative is called a reflection. And what axis will that reflect over? across the x-axis. The vertical reflects across the x-axis. And you'll have a vertical dilation by, how much were we multiplying by? Okay, so that would also occur. I'll let you fill in the values and all that on your own. I've given you the rule. I've given you that. I'll let you do that on your own. And then you have one more DOL listed after, where you have this DOL here. So I'll let you work on that. I'm going to pause. I'm going to show you one thing here at the end. I told you I was going to do this. I'm going to do it now. I almost forgot. This is pretty neat. I spent a lot of time on this. Here, focus here with me for a moment. It's going to look huge for a second. I got to fix my, I had to zoom in for a different class for something different I was doing. Okay, I want to fix my zooming. Okay, I want you to look at this. And if it helps, I'm going to turn off the label so you're not looking as much. What I have here, this relates the unit circle to the graph. It also does inverse. You haven't learned about that. And also has a triangle, which you don't have to worry about that. I just want you to focus on the top. It's going to relate the unit circle up here in the top left to the graph on the top right. Specifically, I'm going to show you how the values work together. Okay, so a unit circle is obviously a circle. The graphs aren't circles. What do the graphs look like?
Waves.
How do I make them correspond? Well, as the angle moves, I'm going to have a little slider here, and I'm going to move my angle. And I'm just going to stop at any random spot right here. What happens on the unit circle is the unit circle value gives you the x and the y. I don't need to touch that because right now I have something going on mathematically. It gives you the x and the y. The y value always corresponds to which function? Sine. So the y height of the circle will always match the y height of the sine. You see how these are the same exact height? You see this? Hey, stay with me just for a moment. I'm not going to keep you after. Those two heights are exactly the same height. They're the same height. Now, this says it's 5 pi over 12 on the x-axis, which means this angle would be 5 pi over 12. That would be 5 pi over 12. If I move around here, I'm going to just pick another spot that an angle you know. At the angle of pi, come on, move. At the angle of pi, tell me about the y value at pi. It's 0. Notice the sine graph over here is 0. But at pi, what's the x value? The horizontal displacement on the unit circle? -1. So what's the graph at on cosine? -1. Do you see how they work together? They actually are moving at the exact same slope. I can prove it to you. I got this built into my graph as well. Watch this. If I bring it over, you'll see. If I put the graphs on top of each other, do you see how the green, the cosine graph is matching the circle perfectly at the start? The problem is, on a circle, it starts to make a circle. Ironically, a circle makes a circle. But my wave isn't making a circle. It's making a wave. So they get off as you go. But you can see this starts with the same exact slope. But that's how the two work together. So again, same values. Whoops. Same values. I can turn on those values and you can see the values always match. They work together. That's what I need you to know.